This is Electrical 1 Test 3. And we're going to start out with some little true-fault questions. And most of this stuff here is pretty straightforward, fairly easy, but I usually try to ad-lib a little bit, and so we can get this stuff done. As cool as that little drawing was, it needs to go away so I don't have an empty board. All right, now then, we got a starter that is a high-torque electric motor that converts electrical energy from the battery into mechanical energy to crank the engine. You got that?
Will either one of these help you?
They will. They will. That one there will be great. That's about what I need right now.
I went out front to Alan's office. He had a double pile of these in the corner. I said, Stacy, I need one. She said, I guess it's okay.
Yeah, I'll use that.
Any rocket shifter grenades, I'll let you handle Cobb tomorrow, okay?
yeah, Cobb will be back tomorrow, okay. All right, now then, the second question. What do you think? Somebody answer this one for me. A no-load test on some starters can be made after the starter has been removed from the vehicle. What do we call that no-load test? Now, what is a no-load test? What is that? Did you find what you needed over there?
It goes from, it's got up here where it's engine repair test 5 and 6, and skips 3 and 4 and goes to 1.
Okay, well, dig your book out and use it. Oh, yes. You don't have a book? I thought I gave you a book. Here, try this one. George, you got your book?
Sure.
You got your book?
Yeah.
Dig your book out and flip him through it. We got to find those answers.
I don't know what this is.
Huh? You and him work together on that. He's got a book over. Get over. Slide over next to him. All right. No load test. What's a no load test? Tell me what a no load test on a starter is. You got that? Huh? What if you take the? Why do we want to do this anyway? What are we doing a no load test? Okay, it's kind of a generic starter right here. Okay. All right. What part of the starter is this? You got a nose over here, and you got a little window with your gear in it, your shaft, and all that kind of stuff. Coming off of here, you got this solenoid. All right. You got this big terminal here that a battery cable comes to. Big battery cable comes to, and then you got two small terminals over here, and then you got another big terminal, and it's got this strap that goes into the starter, right? Okay, so one of these terminals over here is going to, typically, if it's one of those that's got two terminals, the little terminals, one of them is going to be marked S and one's going to be marked I. All right, it may be on different sides, whatever, I don't remember. But whatever happens, you need to be using the one that's S. All right, now that you got this on the bench, you're going to hook one of your jumpers to one of your jumper cable clips. So you're going to use jumper cables on a battery now. You don't need to use no tiny jumper wire for it. And hook one of them to the body of the starter somehow. The other one you're going to hook to this terminal right here. And then you're going to jump power from here over there. When you do that, that causes the solenoid to snap this plunger back in here, and it slaps a copper washer against these two right here, and this current is carried down into the starter. First it comes back and the gear goes into the flywheel, and then that connection is made that spins the starter motor. You do this on the bench. If you've got a starter that's not working like it's supposed to, and it goes rah, 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 so I want to know, to begin with, if my starter is actually operational when I just put it on the bench. Now, if you put it on the bench and you hook a good strong battery up to it, and it goes wing, and it tries to jump off the bench, you know it's a good starter, typically. But a lot of times when we bench test one, we'll see the starter go and it barely will go. All right. And
Not doing anything.
what does that mean?
Battery's out of gas.
Shouldn't be out of gas. They had a quarter of a tank this morning.
Like, you spin over, the tires are cranking.
Yeah, well, we may need to reflash it. Okay, so right here, you're going to do your bench test that way. You understand what I'm saying? Let's draw this a different way so you can see it a little better. You got your starter, you got your solenoid, you got two big terminals, you got two little terminals. One of these is S, the other one's I. This one here gets hot whenever you start it. This is not usually hooked up to anything, so it's usually just a dead post. The one that says S, if you see the S on there, that's a solenoid terminal. And so, you're going to hook, your big old ugly jumper cables out here, and you're also going to hook them to the body of the starter because it's got to be grounded. So the ground is going to go here, positive's going to go here. you jump from here to there, and you do your bench test. That's a no-load test. You can do that, and you can tell if the starter's good or bad on the bench. Now, what if it goes on the car, but it spins like heck on the bench? What are you going to do then? I'm going to give me a breaker bar, and I'm going to put it on the crankshaft bolt. I'm going to see if I can turn that sucker. How hard is it? And one day there was this girl that was in the program, and she called and she said, I ain't going to be able to come to work today because my dad said we got to put a starter on my car tonight. And so I just got no ride. She didn't live very far off. So I sent some of the guys over. I said, go get her car and drag it back over here on the hook. You know, they want to drag it back over here. I said, see what's going on with her car. So brought it in here, and it goes, it wouldn't even turn, dead in the water. So I told Hunter was here then, and I told him, I said, let's get on this crankshaft bolt and see if we can turn this thing. You know, actually we pulled the starter off. We bench tested it, was fine. So I said, see if we can turn the engine. So I went to turn the engine, and I was looking down there with my light when he went to turn the engine, and everything was turning except the air conditioner compressor pulley, and the belt was slipping on it because that bearing had locked up, and there was enough grab on that pulley to where it was keeping the engine from being able to turn it off. So we took the belt off of it, and it went fired up. So always take your breaker bar and turn that sucker and see what's working. I have heard of people going so far as to start changing an engine out because the customer gave them an okay and all, and they found out the water pump was locked up. And it had, you know, had it worked good to turn the engine. Bad news when you get that thing. All right. The battery is source of electric current to operate the starter. Incidentally, number 2 is true. Is the battery the source of electric current to operate the starter? That is not complicated, is it? Number 4, however, the starting system converts electrical energy from the solenoid into mechanical energy from the starter. That is a screwed up deal, and that ain't right. I mean, that is just all messed up. That's a false deal. The voltage drop test is performed while cranking the engine. You've done that, right? You guys done a voltage drop test while cranking the engine? Remember that? Didn't y'all do that the other day? There was a worksheet on it, remember? On that 350? Remember what you did? Can somebody tell me how you do that? Voltage drop test. We're going to start out with the same kind of drawing we had. All right, we're just going to let that be our S. We'll always be on the same side. Okay? Now, if you've got a battery terminal right here, we're just going to draw this real simple. There's your battery terminal, and here's your battery, and obviously your ground terminal's over here, and it's going to the body of the car. Sometimes it'll go right to the starter bolt, so it'll be really good. Now you're going to take our meter and go here, and we're going to connect it there and there. Got it? Touch it right in the center of that post, and we're going to set it up to measure volts, and we're going to spin it over, and what should we see on the positive side? Anybody remember? Less than a half a volt. Less than half a volt. Down here on the other side, we can go from here to there. We're going to measure it. We should see less than 1/10 of a volt. Less than 0.1. On ground, it's less than 1/10. And I learned that a long time ago. And that is one of the most useful things. Everywhere you go now, if you go to some school, like at the training convention that I go to, the Kansas City KC Vision, if you go up there and you go to these classes, you sit down, they're going to be talking about voltage drop all day long. That's what they're talking about. I mean, you voltage drop everything. On the alternator, charging system, you're going to go from the big terminal on your alternator, you know, the old big one that you hook your wire to that's got this hot. It goes to the battery eventually. So you're basically going to hook your meter, there's your positive battery post. You're going to hook your meter up between here and here. With the charging system operating, you're still on more than half a volt drop. What happens if I got drop there? I got resistance somewhere, and that means that everything it's putting out here is not making it to there. That's basically, however much you read here is what's not making it to the destination. It's stopping en route, being dropped by resistance. Okay, and that is 5 is true. 6, rebuilding the starter is a very common service practice. Well, it is, but it's not. And I'm going to tell you the reason that most people nowadays, they have starter shops. There's a shop at Enterprise that rebuilds starters. That's all they do is they rebuild starters. I mean, you basically take the starter in, take starters and alternators in there and they rebuild them. That's what they do, right? All right, so the long and the short of it is, that is supposed to be true, although most shops don't rebuild starters anymore. They just get one from the parts house and they throw it on there. That's usually what they do. Same way with alternators. Years ago, we used to rebuild starters and alternators quite a bit. I mean, but 20 years ago, there was a lot of that went on. Nowadays, not so much. At least not in the shops that I'm, around. You can usually, though, put a set of brushes in a starter. We used to put brushes and bushings in there, You don't hardly ever see that no more. Although there are starter shops that do it, but most of the time, the mechanic is not usually going to do it on his bench. Sometimes he will if it's his car. Low current flows through the starter only when the ignition switch is in the start position. Low current. Low current. What low current are you talking about there? That's actually fault. I mean, I don't even understand why they're asking that question. Only when the ignition switch is in the start position. If there's no starter operation, you're going to have power available there. You're going to have current there at your big battery terminal. But that's actually the availability of high current, but there's not anything flowing. Starter stops cranking the engine when the ignition switch turns to the run position. When you release it from start to run, it does. The overrunning clutch prevents the engine from driving the starter. You know what that is, don't you? Well, the overrunning clutch is when you can grab the gear on that starter drive, and you can turn it. Have you ever worked on a lawnmower? Briggs & Stratton? Okay, you got this little, when you pull that cord, what is that little square in the middle that spool hooks to does what? It grabs the starter, it grabs the engine, and when the engine starts, that little spool stops turning, and so does that little square, and the engine's just sitting here running, this sitting still. That's basically the same thing, except it's got little balls in there, and little dogs. But the overrunning clutch is like it's got some little balls and ramps, rollers and ramps thing in that starter drive, and the starter drive, if you keep the starter engaged, have you ever done that? Ever heard somebody not let off after it started up? Makes all that racket. That's that overrunning clutch in that starter drive. It's like, oh no, let go, you'll tear it up. You're scared to death. But it's made where it can take some of that. Now let me ask you this: how many of you have heard a starter go before it started the car? You ever heard them do that? It'll start spinning and then it'll kick back. It'll just freewheel. You'll hear that sometimes. When you do hear that, it's the starter drive that's causing that problem on the front of that thing. And, starter drives are still something you can buy, and people change them every now and then for that kind of stuff. It's cheaper to buy a starter drive than it is a starter, if you can get the starter drive. Now, you can't get a starter drive for every starter, but your older starters you can. All right. Let's see. Gear reduction increases starter torque by decreasing the gear ratio. Do you know what that is? You ever pull a starter apart and see the reduction gears in it? These little permanent magnet starters have got planetary gear set in them. If you pull them apart, and I got some out here we can take down, you're going to look into them. As a matter of fact, usually what I do in this particular class is I'll let you tear some starters apart and put them back together and then mix test them. And I got some under the bench we can do that with. It's pretty cool. You see what's going on in there. It's really neat. But the permanent magnet starters, we got little planetary gears. And the motor is little, and it spins really fast, but it's hooked to some planetary gears that bring the torque up. Chrysler was doing that back in the 60s. And you might remember some of the Chrysler stuff ages ago. We go, yeah. Had a strange sound when they start. It's a real good starter, though, real solid. The motor didn't have to work all that hard, but the reduction gears in there would enable it to do a ton of work without, pulling a lot of current. An electrical device in a starting system that opens or closes a circuit in response to a voltage signal is what? Opens or closes a circuit in response to a voltage signal. What is that? Which one is that? Is it C or D?
D.
Or B? Number 11? C is not a bad answer. That'll do. Opens or closes a circuit in response to a voltage signal. But, listen to this. A starter solenoid would also fit that description, because it does the same doggone thing. Let's see. The blank test measures battery voltage and current during engine cranking. Battery voltage and current during engine cranking. Number 12. That's B, cranking voltage current draw. If you are wanting to see how much current does a starter usually draw on a healthy system, like if one of these cars that we got out here starts just fine, if we get out here with our charging system tester and we hook that inductive probe around the starter wire and we spin the engine over, what are we going to see there usually on a normal starter? Now there was actually a worksheet I gave you guys on that, I think already, where you're supposed to check a starter draw. Do you remember any of you remember what it's supposed to be? About 175, 200 amps tops. Supposed to be there if you got everything healthy. And a voltage drop test, normal voltage drop should be what? And this is on the positive side. What I put up here?
Less than a half.
Less than a half, that's right. A basic starting system complaint is that what?
All of the above.
Yeah, could be any. So it's a starter. Now you got to learn the semantics of this too. If somebody is, if I've got my engine, and if I go out here and I'm going, and then you start, what do you call that? If you're writing it up so somebody can understand it. If you had to write the ticket, so somebody, what would you tell them? What words would you use? You don't want to fill up too many lines. The fewest number of words you can. How about cranks normally but won't start? Cranks means ring. Because some people say my car won't crank. And so you say, wait a minute, what do you mean by that? You know, well, when I try to start it, it just spins over. Well, it does crank, but it doesn't start, you see. And occasionally, we would have one that the ignition switch just all of a sudden wouldn't turn. It was the right key, but you couldn't get the lock cylinder to turn, I say. And we've had that 2 or 3 or 4 times on different vehicles here. That Chevy van that we got did that. Joey pulled it in there with a bunch of students in it coming back from a field trip to get some gas and tried to start it, and it was like he had the wrong key. What do? You got to drill it out, put another lock cylinder in. Okay, we had a Saturn that did that. We had a Jeep Cherokee that did that. I mean, any of them can do it. And you know, got to be able to drill them things out and replace that lock cylinder. But one day, and I had a bunch of them do it at the Ford place. You know, Thunderbirds would do it in various different vehicles. You just all of a sudden, hey, I've got the right key, I know, but it just won't turn. Well, that lock cylinder, parts of it's come apart down in there, and it just won't move. And so one day they says, hey, we got there's a bucket truck out there that, you know, they hand me a ticket for a bucket truck. And they says the lock cylinder, I mean, they said they don't know if it's the ignition switch or the lock cylinder, but they can't start it. And so I walked out there, I climbed up in this, and this is a perfect storm, guys, that's what I'm telling you. I walk up here, I get up in this white bucket truck, I stick that key in there, I gotta turn the ignition switch, and it won't turn. I said, oh yeah, I've seen this before, this ignition switch is bad. Now sometimes, you know, those old ones that had the old metal bat wings on it, you know, you can, if you use both hands, you can get a pair of channel locks and turn your key at the same time and just crunch that thing on over anyway. And then when you get it there, it's really easy to push that button and jerk the lock cylinder out if you're in the home position. So I got my channel locks, and I walked out there and stuck that key in there and cracked that thing, cranked it over, and fired the truck up, drove it into the shop, and changed out the lock cylinder. And about the time I got the lock cylinder changed out, our maintenance man walked up and says, what are you doing to our bucket truck? I said, this was supposed to be a P River electric bucket truck. He said, I didn't even know we had a bucket truck. And he goes, yeah, we just got one. Well, I had fixed the wrong bucket truck. The key they gave me fit the P River electric bucket truck, and I tried to start ours, and obviously it wouldn't fit. But the problem I was supposed to be fixing was this same thing, you see. But that other truck had some other problem. It was an ignition, the electrical part of the ignition switch. But I felt silly then. You know, the shop spent $50 on a lock cylinder, you know, no reason. Boy, I started that thing anyway. All right. The basic starting system complaint is what? Yeah, we already said that. Excuse me. The pinion gear must rotate 15 times to rotate the ring gear once. If the starter operates at 3,000 RPM, it will crank the engine at what?
200.
Yeah, so it's 15 to, yeah, that's about the only answer that works, really. You know it's not going to crank it any faster than that. Is that your last question? That is, isn't it? Okay. All right. There's a bunch of matching questions that are on my original test, but I don't usually print those. All right. That's the end of electrical systems test 3.